How do you check a system when its maker admits the tests that they use cannot fully see that system anymore? Anthropic says its evaluations no longer capture increases in models' capabilities. That leaves the public trying to judge a hidden, closed model through the company's own redacted report. Now here's the claim I'll stand behind. A maker that can't measure its own creation but chooses to stay closed has no credible right to remain its only safety judge. That's today's lead. Also in today's episode, whether newer training methods can close the gap without more computing power, how communities decide who bears the physical costs of new data centers, and a microscope fast enough to track the brain in real time. Come with me, let's get into it. Everyone asked to trust Anthropic's safety judgment is now standing outside a locked room. Inside that room is Model 2, an unreleased system that Anthropic says is more capable than Mythos 5 models that it currently provides to select partners. The company says it has no plans to release Model 2 for outsiders to test. So who can tell whether Anthropic's safety rating is actually right? Anthropic raised its own misalignment risk rating from very low up to low, and it said that it made the change to reflect increased uncertainty about risk in light of recent disclosures. Now that sounds like it's cautious, but it also asks the company's customers and the public to accept a grade that the company assigned itself. The public version is a redacted 186-page report. Anthropic can examine the hidden model, but outside researchers can't. Anthropic knows what it removed from the report. Everyone else just sees black boxes. And this arrives as Anthropic explores a potential public offering when investors are watching both capability and risk. Now, a lower rating helps the safety story. A more capable hidden model helps the growth story. Anthropic benefits from being believed on both counts with no actual verification. Now, two admissions in the report matter far more than the label that we're being provided here. First, Anthropic says that Claude authors a large majority of the code merged into our production code bases. And then the company also adds that AI has sped up its research and development, not yet by a factor of 2. But even just under a factor of 2 is still a lot. Now, those two statements together describe a feedback loop already taking shape. Claude writes most of the production code inside the company building Claude. Anthropic says the total speedup remains just below a doubling, but that the system is already working on the machinery that produces its successors. And then comes the even harder admission. Anthropic says its task-based evaluations no longer capture increases in models' capabilities. In other words, the measuring stick has been passed. There are no more markings. A benchmark can still return a score after that happens, but the trouble is that score stops telling you how much the system really changed. So imagine the speedometer on your car. It usually tops out at about 120 miles per hour. Once the needle hits that limit, it can't distinguish between 130 miles per hour or 500 miles per hour. Anthropic has started building another measure too with outside collaborators. Its Conceptual Reasoning Index tests how well models reason through AI safety arguments. Opus 5 scored 73.6 against a ceiling near 91. Anthropic says that these scores have been increasing roughly linearly since late 2024 with no signs of flattening. Now that index measures one part of the problem. It doesn't give Model 2 an independent safety certificate, and outsiders still can't inspect the hidden system. Now, Axios reported a parallel sign over at OpenAI, which has slowed its Astra model over concerns about critical cyber capabilities. Two leading labs then are now describing systems that have strained familiar testing or release procedures. Now, the companies may have good reasons to keep a specific dangerous capability contained. Public release cannot be undone, that is true. If regulators impose a narrow pause tied to a specific risk, then researchers gain time to build a better check. But secrecy can't certify itself. If one company controls the model and the evidence and the test condition and the final rating, the public can't check the party asking for its trust. Anthropic deserves credit for even admitting that its old tests have gone dark. That admission points beyond Anthropic, though. Frontier systems now need the equivalent of an independent crash test. The lab can build the vehicle and run its own checks. Someone without a stake in the sale still needs to hit it, to measure what happens, and to publish the result. All right, while Anthropic keeps its stronger model in-house, teams priced out of a fresh frontier training run just got a much cheaper route to capability. Z.ai shipped GLM-5.3 on August 14th, just a couple days ago. It reused the 743 billion parameter base from the previous version. There was no new pre-training run. So how much can you gain when the underlying model stays frozen? Retraining is the expensive foundation. It demands huge chip clusters, vast datasets, and capital that only a few organizations can raise. Post-training happens afterward. A team gives the existing model better practice environments, stronger feedback, and more chances to refine how it uses what it already learned. Others can reproduce that work more cheaply, faster, and more easily. So the foundation stayed in place. Z.ai rebuilt everything above it. Now, Terminal Bench tests coding agents inside a computer terminal, and the model score there went from 4.6 to 28.3. That's roughly a 6-fold jump from post-training alone. On one cyber defense test, GLM 5.3 reached 84.5%. Mythos 5 scored 83.8%. On that test, the open-weight competitor is narrowly ahead. But another exploit test gives us the needed restraint here. GLM 5.3 more than doubled its earlier score to 54.4, but Mythos 5 stayed far ahead on that one at 78. So this model is closing the distance on the frontier, but it has not yet cleared the frontier across the board. Reuters reported that GLM 5.3 flagged 2,436 vulnerabilities across 269 projects. Z.ai calls it the top of the open-weight coding model list. It also costs roughly 1/10 the per-token price of some of the leading US systems, and Z.ai says it saves even more on some tasks by needing fewer tokens. Now, that combination changes the concentration story. A team that can't afford a fresh frontier training run may still need to pull a major capability gain from a base that it already has. The most valuable improvement may live after the part that export controls and chip restrictions can most easily constrain. Z.ai itself is on the US entity list, yet post-training still gave it a roughly 6-fold jump on Terminal Bench 3.0. The route around the compute gate didn't require a new foundation. Now, the weights aren't available yet, which is a bit of a step back from what they did last time, where they released the weights immediately for GLM 5.2, almost in response to the whole fiasco of Claude holding back Fable after releasing it and pulling it back. Z.ai released the previous model under the MIT license on launch day. This time, though, Z.ai says it's holding the weights for about 2 weeks while it runs a safety review. That places Z.ai beside Anthropic, holding Model 2, and OpenAI slowing Astra, not to mention what's happened in the past. 3 organizations are applying different forms of delay around systems with stronger capabilities in particular areas. A focused review can help when a model's cyber capability jumps this quickly. The unresolved problem is who controls the test. When the maker chooses the criteria and runs the evaluation and decides what outsiders get to see, that review has the same weakness as Anthropic's private rating. Now, the capability gain came through a method many more teams can use. Once the weights arrive, the biggest result then may be this. The expensive base model no longer predicts how capable the finished system becomes. All right, that cheaper route still needs power and land, and families beside proposed data centers are deciding what they're willing to host. Can communities turn opposition into accountable infrastructure without pushing every rejected project toward people with less power to refuse? Canary Media surveyed local races during 2026 and found data center siting becoming a decisive issue from Virginia to Michigan. Candidates who campaigned for moratoriums or stricter zoning won seats on the councils and boards that approved those projects. That's direct authority over siting. It follows more than 500 local measures seeking to ban or restrict data centers documented nationwide by July. Now, the reasons vary sharply by place. In Larbert, Scotland, Police Scotland warned that a proposed data center could draw sustained public opposition. The plan places diesel backdrop generators near an 860-bed hospital and a care home. Those generators would release nitrogen dioxide during testing and outages. Police Scotland warned that the site then would need robust security against protest. Air pollution beside a hospital is a planning and a health question. Treating anticipated opposition mainly as a security problem risks placing ordinary public objection in the same box as violence, and that's not correct. In a Warsaw suburb, residents are protesting a planned campus over its projected draw on the local water system. A raw water figure proves little by itself. Agriculture and heavy industry can dwarf one data center's use, but aggregate share and local strain are 2 different questions. A single campus drawing heavily from one municipal system in a place that already has to watch its water use deserves a very clear accounting. And then there's Marshall, Michigan. After the local authority voted on a data center moratorium, officials received threats serious enough to trigger a criminal referral. The editor's preparation says that one was a death threat. Those threats are violence aimed at people carrying out their public duties. They also don't represent the overwhelming majority of opposition, which is moving through elections, public comment, and planning law. Flattening those groups together would make a violent and unacceptable fringe the public face of residents who are trying to just use lawful authority. The civic route is already gaining power because each win produces something that the next town can use. One council writes ballot language, another copies its zoning ordinance. Residents in different places compare operators and learn which promises require binding terms. Accountability gets cheaper to draft with every contest in this. Communities that push for this can get cleaner siting, enforceable water and air protections, and a clearer deal on who pays for the grid upgrades. The build-out needs those rules because the infrastructure itself is indeed necessary. When there's more compute, more people can get access to intelligence, medicine, science, and engineering. What's undecided is whether its physical costs get hidden or shared honestly. Local refusal alone cannot guarantee justice. Wealthy communities have long defeated unwanted projects and watched them move toward places with less money, fewer lawyers, and weaker political access. Landfills and incinerators followed that path for generations. Data centers can follow it now. The hopeful part, though, is that residents are building a reusable civic language around the terms of construction. The next step is making that authority travel, so a strong town's protection doesn't become a weaker town's burden. All right, shifting again, communities are deciding where intelligence infrastructure belongs, but neuroscientists face an even faster problem. Brain cells coordinate in thousandths of a second, while most whole brain measurements only capture activity every few seconds. So how do you watch a whole living brain without missing the electrical conversation that even makes the brain work? For most of the history of neuroscience, researchers have had to choose between recording direct electrical activity from a small group of cells or watching much more of the brain through a slower chemical trace. That slower method follows changes linked to a neuron firing, but by the time the signal appears, some of the fastest action had already passed. A brain also computes across different regions. Watching just one small area can miss how a distant cell coordinates in order to turn a sensation into a response. MIT engineers in Ed Boyden's lab have now combined two methods to close that gap. They engineered neurons with fluorescent proteins that light up the instant a cell fires, and then they speed up a microscope that illuminates thin layers of tissue and stacks them into a three-dimensional view. The old view was closer to a long-exposure photograph. This instrument records high-speed video. It scans the entire brain of a living zebrafish at 200 times per second. One complete scan takes 5 milliseconds, fast enough to catch individual electric spikes and rapid bursts. Co-author Ji Zhang put it like this: neurons compute using electrical activity, so with voltage imaging, you can get direct observation of that. The team exposed resting fish to ultraviolet light. Activity appeared first in the part of the brain that handles vision. It then spread across that region, followed by organized firing through deeper parts of the brain. The researchers could then watch that coordination unfold across an entire living vertebrate brain at the same speed that the cells were actually going. Now, there are still limits, of course. The fluorescent indicator produced usable signals in only about a quarter of the neurons. The subject was only a larval zebrafish, whose transparent body does make it unusually friendly to this kind of imaging. A mouse brain is vastly larger. The team still needs higher coverage and faster scanning before it can tackle that next target. So this does show that researchers can follow a whole living brain's electrical activity in just milliseconds, but of course it isn't a new finished brain atlas. In March, we covered a complete fruit fly wiring map driving several behaviors inside a simulated body. That project showed what can happen when researchers know how the neurons connect. This microscope adds the living activity those connections carry. A static wiring diagram tells you what could communicate. Millisecond imaging shows the conversation itself. All right, let's close it for today. So who checks the makers once their own tests can't keep up? No single institution can give us that answer today. Researchers are starting to piece the answer together, though. Anthropic admitted that its familiar evaluations no longer register further capability growth. That makes independent testing a practical need rather than a distant policy idea. Z.ai showed why the check can't become a gate controlled by today's largest labs. Capability can arrive through cheaper post-training from a company already placed behind a national technology barrier. The review system has to follow the capability without freezing open access or protecting whoever currently leads. The communities are building their own checks at the physical layer. They are winning seats, writing zoning rules, and demanding clear terms for air, water, land, and power. That authority works best when it travels, so that protection in one town doesn't simply relocate the burden to another. And MIT's microscope gives us the cleanest image of the day, pun intended. When an old instrument moves too slowly, you build one that can see the system as it runs. That's the work ahead for AI, too. Better measurements, outside access, public results, checks that remain useful when capability crosses the older scale. Anthropic's report is where the company admitted the needle has hit the end. GLM-5.3 is where capability arrives through another door. Local elections are where people gain authority over the physical terms, and the zebrafish experiment shows what becomes possible when measurement finally starts to catch up. The future won't be secured by asking makers who are motivated purely by profit and keeping their systems closed to just describe themselves more convincingly and openly. The future gets safer and broader and easier to trust when people outside the room can see what was built and test it for themselves and show it to everyone else. We'll see you tomorrow.